Have you heard this yet? In the next 48 hours, an object from a distant star system will pass by Mars. It's called 3I Atlas, a traveler moving through space at more than 137,000 miles per hour, a speed that has captured the attention of scientists everywhere. NASA hasn't said much. No press releases, no public statements. All observations are being kept quiet, while orbital instruments and radar continue to record data in silence. And if you can feel that same silence, tell me, where on this planet are you? Leave a small sign in the comments, so I'll know you're also looking up at the same sky. 3I Atlas originates from interstellar space. It has no stable orbit and behaves unlike any known comet. Its reflected light changes in cycles. Its gas emissions fluctuate unpredictably. Every signal points to the same conclusion: this object is unlike anything else. Observatories across the globe have begun tracking it. Over 200 facilities are now collecting data, and each new record shows another anomaly. Researchers are beginning to suspect that this may not be a natural body of ice and dust, but a controlled system. In the darkness, among billions of drifting celestial objects, a faint signal is moving toward us, and humanity does not yet know whether it is witnessing a natural phenomenon or receiving a message. At Harvard, the data on 3I Atlas was re-examined. Measurements revealed that the object was releasing almost pure carbon dioxide with barely any trace of water, and there was the presence of nickel, but no iron. In the universe, that should be impossible. Nickel and iron are always forged together in stellar explosions. Their separation shattered every conventional hypothesis. Professor Avi Loeb assessed the probability that the object had a technological origin as 6 out of 10, 60% unnatural, 40% still uncertain. The scientific community reacted fiercely. Some dismissed the idea outright. Some remained silent, but no one could explain the numbers. 3I Atlas was not merely a comet. It posed a far deeper question. Could something out there be sending a signal to us in a language science has yet to understand? Telescopes began returning unmistakable signals. 3I Atlas reflected light in an unstable pattern. Its brightness fluctuated in steady rhythmic cycles, almost like a programmed pulse. Spectroscopic sensors detected strong gas emissions, but unlike other comets, there was no trace of water vapor. The main components were pure carbon dioxide and nickel, with no sign of iron. Radar readings showed an unusually stable trajectory. There was no orbital deviation, even as the object continued venting large amounts of gas. That suggested either an immense mass or an extraordinarily resilient internal structure. Data from more than 200 observatories across the globe was compiled, and every record confirmed the same thing. 3I Atlas was not behaving like a comet. It was doing something else. When the data was circulated internally, research teams across the world began to argue. Half believed it was a measurement error. The other half believed they were witnessing something entirely new. Analyses began to flood in. Some claimed 3I Atlas was merely an unusual comet. Others insisted no known comet could emit pure nickel. Existing physical models no longer fit. No orbit, no composition, no reflective pattern matched the data. The more they tried to explain it, the more confusing it became. A few scientists began to suspect that this might be an artificial object. a device designed to travel between star systems, a form of technology either ancient or thousands of years ahead of humanity. No one dared to make a definitive claim, but everyone felt the same thing. A quiet unease spreading through the scientific world. 3I Atlas had broken the certainty of knowledge. As the news spread, observatories across the planet turned their telescopes toward 3I Atlas. From Chile to Hawaii, from South Africa to Japan, hundreds of telescopes tracked the same faint point of light in the sky. More than 227 observation stations sent data back to central hubs. Each new record revealed something stranger than the last. No one could find any trace of behavior typical of a comet. Sensors detected cyclic variations in brightness, light intensifying, then fading, then returning again, following a steady rhythm, as if under control. Some astronomers began to suggest that the object might be actively modulating energy in response to its surroundings. The gas emissions grew stronger with time. No water vapor, only carbon dioxide and traces of pure metallic elements. Its orbit remained impossibly stable, showing no wobble, even as it shed hundreds of tons of material each day. The numbers rendered old models useless. No one was certain what was real anymore. And so, 3I Atlas became the center of every major scientific discussion that year. As all the data came together, a larger picture began to emerge. 3I Atlas was not behaving like a comet. It moved like a system with order. Each time it approached the sun, it reacted in the same rhythm. Its light, its gas emissions, and its trajectory shifted in perfect synchronization, not random but structured. Scientists compared data from multiple observatories around the world. The results matched precisely. Every measurement confirmed that the object maintained a consistent internal rhythm throughout its journey. Some teams reconstructed its trajectory using advanced physics simulations. They discovered that, to maintain such stability, the object would have to actively adjust its own direction. No comet in history had ever done that. And when researchers looked back across thousands of data points, they realized the strangest thing was not the numbers themselves, but how they connected. Everything seemed to follow an internal logic, a design or pattern that humanity had never before understood. As the data grew stranger, new hypotheses began to emerge. One group proposed that 3I Atlas could be the remnant of an ancient, shattered planet, its metallic core compressed over billions of years, producing the rare and unnatural composition we see today. Another group turned to quantum theory. They called it a Q-ball, a macroscopic quantum entity with a stable, self-sustaining energy field. If such things truly exist, they could persist for eons, drifting between star systems without losing power. But there were those who asked the uncomfortable question: if this were only a physical phenomenon, why did it appear now at the very moment humanity had the technology to observe it? And why did its path pass so precisely by Mars? Amid the debates, one truth became increasingly clear. 3I Atlas was not just a nameless block of ice and rock. It had behavior, it had rhythm, and perhaps it had purpose. If you're listening, let the soft blue glow of your screen be a small light in this vast space. A gentle tap on the subscribe button will make sure we don't lose each other among the billions of stars. Because someday, when the universe finally speaks, you might be the first to hear it. As the debate spread through the scientific community, NASA remained silent. No statements, No denials, no explanations, only quiet data releases. Numbers precise to the point of coldness, no emotion, no conclusions. Yet anyone who knew how to read them could see it. Something wasn't right. The silence wasn't random. It had structure, intention, as if it were part of a larger picture we were not yet meant to see. Some research teams were told to stop publishing. Some observations were suddenly postponed, without reason. And while everyone waited for answers, 3I Atlas kept moving. It passed Mars, drifted closer to the sun, and then vanished into the blinding light of the solar glare. No one knows what happened on the other side. We only know this. Sometimes, the universe doesn't need to say anything at all. It just stays silent and lets humanity discover the rest on its own. As 3I Atlas moved deeper into the region near the sun, orbital instruments began detecting strange signals. Radar and spectroscopic sensors reported steady oscillations unlike any natural reflection ever recorded. The intensity of its light shifted in a repeating cycle, as if following a pre-programmed rhythm. Observation spacecraft from NASA and ESA both confirmed the phenomenon. The reflected light of 3I Atlas was no longer random. It repeated. It stabilized. It formed a pattern. It looked less like reflection and more like transmission. Some scientists dismissed it as technical interference, but when instruments in separate orbits, operated by different agencies, detected the same frequency, the hypothesis of mechanical error quietly faded away. If you're still listening, let yourself drift with that pulse. Subscribe so that whenever the universe sends another signal, we can listen to it together before the light dissolves into the endless dark. When the data was compiled, researchers found that the signal repeated every 11 hours, exactly matching the brightness variation of 3I Atlas. That meant the object wasn't just reflecting light, it might be transmitting it deliberately. Though NASA maintained silence, independent observatories began picking up the same frequency within their range. Each time 3I Atlas passed by, a faint pulse echoed through space, steady, unwavering, like the breath of something alive. And if that is true, then perhaps we are not simply watching an object. We are hearing a voice, ancient, patient, and impossibly far away. October 3rd, 3I Atlas drew closer to Mars than ever before. Telescopes recorded an unusually intense reflection. Across its surface appeared symmetrical points of light, like fragments of mirrors, arranged with precision. October 30th, 3I Atlas passed behind the Sunday. From Earth, no instrument could see it anymore. For the next 2 months, there were no signals, no light, no reflections, only a perfect silence suspended in space. December 3rd, 3I Atlas reappeared. Its light was weaker now, but the reflection frequency had changed. Its trajectory had shifted slightly, as if something had happened on the far side of the Sunday. Scientists debated furiously. Was the change the result of gravitational influence or an intentional act? No one could say, but everyone agreed it was not random. When the new data was compiled, 3I Atlas showed an orbit unnaturally stable in its new path. No known force within the solar system could have produced such precision. That's when the term self-adjusting mechanism began to surface. Some scientists proposed it might be the remnant of an ancient construct. Others argued it could be a physical process not yet understood. But a few suggested something quieter, Perhaps it was never meant to send a message at all. Perhaps 3i Atlas was simply doing what it was made to do, and we just happened to be watching. As its final light began to fade, the telescopes shut down one by one. On their screens, only a small dot remained, slipping away into the endless black. In the control room, no one spoke, because sometimes the universe doesn't answer with words, it answers with silence. And within that silence, everyone understood. The dialogue between humanity and the cosmos had only just begun. The story of 3i Atlas may have ended, but the universe has never stopped moving. The light you see tonight left its star millions of years ago, arriving here now, at the exact moment you're listening. Each photon is a small message, each grain of cosmic dust an ancient memory, and perhaps we've only just brushed the edge of something still being written. 3i Atlas has gone, but the questions it left behind remain. Questions of origin, of intelligence, and of the limits of what we call natural. Tonight, if you look up at the sky, imagine that somewhere among those billions of lights, one of them might be looking back at you. Because sometimes, the universe doesn't tell its story in words, but in the way it leaves us utterly silent. In the world of science, every discovery begins with doubt, but the doubt that Avi Loeb brought forward was unlike any other. It made the entire global scientific establishment pause for a heartbeat. From his office at Harvard University, where light filtered through layers of optical glass, Loeb examined the first streams of data on 3i Atlas. Not everyone could see meaning in those numbers, but to him, it felt like reading a foreign language, one the universe was trying to speak to humankind. The charts showed something extraordinary. The object was releasing carbon dioxide at almost pure concentration, 95% CO2, 5% water vapor, a ratio impossible in nature. Ordinary comets are built with vast amounts of water ice, but 3i Atlas was different, dry, cold, and far more reflective than any prediction. Even stranger, the spectral analysis revealed the presence of nickel, a heavy metal usually found together with iron in celestial bodies. Yet here, iron was completely absent. An impossible ratio, since both elements are born together in supernova cores and cannot separate without artificial interference. Loeb jotted a single line into his notebook. If this is correct, it isn't a comet. When other telescopes, Hubble, James Webb, and the Very Large Telescope confirmed the data, he knew this was no longer a matter of curiosity. Loeb published a short commentary, stating that there was a 60% chance 3i Atlas had a technological origin, 6 out of 10. Not a declaration, just a careful assessment, an honest ratio between evidence and possibility. That was enough to ignite the scientific world. Many called him a dreamer. Some accused him of leading science into mysticism. But others stayed silent because the data they held in their own hands contained something that could not be explained by classical physics. The headlines followed. Harvard professor suggests alien technology may exist, but Loeb hadn't declared anything. He had only given a number, a small one, yet enough to split the worldview of modern astronomy in two. What unsettled academia wasn't the number itself, but who had said it. Avi Loeb was not a sensationalist. He had led major projects on dark matter, worked with NASA on exoplanet detection, and served as a senior advisor for the Smithsonian Astrophysical Observatory. For a man like that to say there was a 60% chance 3I Atlas was not natural meant he had seen something worth risking his reputation for. Critiques arrived in waves. A team at Oxford claimed the nickel data could be a scattering error. Another at Caltech argued that the CO2 imbalance was caused by unstable reflection angles. But none of them had more complete data than Loeb. In a brief interview, he said simply, "We could be right, we could be wrong. But science must follow the data, not prestige." The phrase spread like wildfire. Simple but heavy, a quiet challenge to the entire conservative framework of modern science. The press took sides. Some praised his courage. Others wrote that he was blurring the line between theory and belief. But Loeb didn't argue. He just kept observing, quietly adding new lines to his reports. By mid-April 2025, when 3I Atlas reached 3 astronomical units from the Sun, observatories in Chile and South Africa began reporting a sharp increase in emission intensity. The surface temperature of the object spiked, far beyond what any icy comet could endure. Physicists tried dozens of models to simulate the phenomenon. Every single one failed. No natural process could maintain structural stability under such violent outgassing. Once again, Loeb wrote in his notebook, "If it doesn't melt, it isn't ice." After the 6 out of 10 assessment was published, the first response came from the International Astronomical Union. They sent a letter to Harvard requesting clarification on the analytical methods. Spectroscopy labs in Germany and Japan were assigned to verify the data. The results only deepened the confusion. Each lab reported slight variations, but all confirmed 2 facts: an extremely high concentration of carbon dioxide and a complete absence of iron. In an internal report, a physicist in Tokyo wrote, "Without iron, this object could not have formed naturally. The only process capable of such separation would be high-temperature refinement." That short, technical note, when leaked to the press, became a headline. "Interstellar object may have been manufactured. It's Sumulhide," and one comment. From that moment, the story escaped the realm of science. Talk shows, podcasts, and newspapers began debating it. Avi Loeb's name echoed across every platform. Harvard remained silent, but inside, the pressure was growing. Many colleagues believed he was damaging the university's reputation. A few quietly supported him. They knew the data couldn't simply be ignored. When asked about the controversy, Loeb smiled. He said, "Every new truth begins with denial." Galileo was called a heretic. Einstein was accused of breaking physics. And perhaps 3I Atlas was just repeating that story. In another century, he wasn't seeking attention. He was seeking an answer. If 3I Atlas truly was extraordinary, it could open an entirely new field in interstellar physics. If not, at least it would teach humanity the limits of what it knows. But the media cared little for boundaries between data and philosophy. They wanted answers now. A headline in Scientific Times read, "Harvard suggests artificial object beyond the solar system." That single line drew millions of eyes and forced NASA to respond. Their spokesperson said tersely, "There is currently no evidence suggesting 3I Atlas is artificial." But they didn't deny the possibility. For the first time, the words "maybe" appeared in an official NASA statement, and that alone was enough to change everything. Now, the question was no longer, is it real? But if it is, why now? Research institutes across Europe, Asia, and America began forming dedicated task groups. They gathered data from the James Webb Space Telescope, and cross-referenced it with radar and atmospheric satellite readings. Working independently, they all arrived at the same quiet conclusion. 3I Atlas was not behaving like a natural object. The only question left was, what is it? The pressure was mounting by the day. Internal meetings at Harvard became constant. Several scientists urged Avi Loeb to retract his 6 out of 10 assessment, arguing that while it was meant as an academic estimation, the public had misunderstood it entirely. But Loeb refused. He said misunderstanding should never be a reason to stay silent in front of data. If fear of criticism prevents people from speaking what they see, then science stops moving forward. That sentence spread faster than the original paper, not just for what it said, but for the unwavering calm of the man who said it. To put an end to pointless debate, Loeb made a bold decision. He released everything: spectral data, gas analysis, light curve sequences, all of it. He uploaded the complete dataset to Harvard's open archive, free for anyone to download, inspect, and challenge. That single act forced the scientific community to respect him. Few scientists in history have been willing to place their entire body of work on the public scale. Independent teams began to rerun the simulations. A laboratory in Paris published a report confirming that the reflective behavior of 3I Atlas could not be replicated by any known cometary material. A group in Singapore used machine learning algorithms to compare the light spectrum of 3I Atlas with more than 10,000 cataloged celestial objects. The result: no match whatsoever. The statistical distance was so vast that by data alone, 3I Atlas clearly did not belong to the solar system. By making the data public, Loeb had inadvertently turned his study into a global scientific wave. What began as doubt became an open challenge to every lab on Earth. In a short address, he said simply, "If I'm wrong, show me where. If I'm right, let the data speak for me." The room fell silent, not because he was persuasive, but because he was sincere. Then, amid the growing tension, NASA released new images from the James Webb Space Telescope. 3I Atlas appeared in greater detail than ever before. Its surface was not smooth. It was angular, faceted, reflecting light differently across distinct regions. The scientific world split instantly. One camp called it a reflection artifact. The other believed it to be structural, possibly artificial. Loeb made no comment. He only said quietly, "We are witnessing something that current physics cannot yet explain. And when that happens, the only thing to do is to keep observing." In science, it was a simple statement, but also the most powerful admission of all, that humanity still does not fully understand its own universe. When the new data was released, the scientific debate reached its most intense stage. NASA, ESA, SETI, Oxford, and Harvard all joined a series of closed conferences. No one was asking whether to believe anymore. They were asking whether science itself was ready to accept something it could not yet explain. Every existing physical model had failed. No equation could replicate the behavior of 3I Atlas. One researcher summed it up in a single line: "If the laws aren't enough, perhaps it's time to rewrite the laws." The media called it an academic earthquake. Just one number, 6 out of 10, had shaken the boundary between knowledge and belief. Nature published a rare editorial that read, "Perhaps science doesn't need more answers, but needs to learn how to live with unanswered questions." It was one of the few times a major journal acknowledged that silence itself can be part of knowledge. SETI announced that no radio signals had been detected, but they could not rule out the possibility. that 3I Atlas communicated in another way. That single statement forced every assumption to be reconsidered. Avi Loeb did not argue with anyone. He simply said, "I am not claiming 3I Atlas is technological. I'm only saying the possibility is greater than we've allowed ourselves to imagine." The words spread, and with them, the way humanity looked at the universe began to shift. The line between natural and artificial, between physics and the unnamed, grew thinner and thinner. In that quiet, the scientific world began to reflect, and sometimes it is from that silence that the real turning points begin. After the final conference, Avi Loeb quietly vanished from the public eye. No more interviews, no more commentary. He left behind only short reports, updates from observatories, data summaries, and never again mentioned the 6 out of 10. Harvard stayed silent. Journals stopped arguing. The academic earthquake subsided, but the cracks it left in the foundation of scientific thinking remained. A year later, new papers began to appear, built upon the same data Loeb had once shared. No one mentioned his name, yet their work followed the path he had opened. And quietly, a new generation of scientists began to emerge, ones unafraid to ask questions and unafraid of the universe's silence. In his final short note, Loeb wrote, "3I Atlas was never just an object. It was a test of humanity's curiosity. And friends, the Terry Den, open Ru eyes." That single line closed his academic journey, but opened a new chapter for science. Not through the noise of discovery, but through the humility of admitting that sometimes not knowing is part of understanding. The telescopes kept watching, recording the faint traces of 3I Atlas across millions of data points. No one knows when humanity will truly grasp what it left behind. But because of that moment, science itself changed. It no longer hid behind equations alone, but began to open itself to the unknown. And somewhere out there, in the dark expanse, perhaps 3I Atlas is still drifting, carrying the question a scientist once dared to ask, and leaving its answer for another generation to find. As 3I Atlas drifted beyond Jupiter's orbit, the major observatories began to scale back their tracking. NASA went quiet. ESA released only dry technical updates. And the academic world was still circling around that now legendary phrase, 6 out of 10. But what no one expected came not from billion-dollar telescopes, but from the hands of ordinary stargazers. On a quiet night in early May 2025, in the southern countryside of Chile, an amateur photographer named Raul Ortega was taking long exposure shots of the Milky Way. He didn't know that, in one of those frames, a faint streak of light appeared, moving slowly across the eastern edge of the sky. Raul assumed it was a Starlink satellite, but when he compared it to orbital maps, there was nothing in that position, not that night. He uploaded the image to an amateur astronomy forum. Within hours, a user in Poland, then another in Japan, said they had captured the same faint streak, same angle, same direction, same time. When the images were aligned, a clear shape began to emerge. It wasn't a blur, but a structured, triangular reflection, flashing in a steady rhythm. The amateur astronomy community erupted. Hundreds of observers pointed their lenses toward that region of sky. Within 2 weeks, more than 1,000 images had been uploaded. Everyone showed the same object, moving with precision, its brightness constant, emitting a pulse every 3 minutes. No one dared claim to know what it was, but orbital tracking software confirmed the coordinates. It matched 3I Atlas exactly. NASA gave no comment. ESA issued a brief note, acknowledging there was a possibility the object was indeed 3I Atlas. By then, the media had already taken over. Headlines blared. Amateur astronomers capture clearer image of interstellar object than NASA. Thousands of comments flooded online forums that night. Some called it proof of extraterrestrial technology. Others insisted it was cosmic dust reflecting sunlight. Raul, the man who took the first image, said only, "I don't know what I photographed. I just know it didn't look like anything I've ever seen in this sky." Scientists could no longer ignore it. A team at the Geneva Observatory began compiling amateur data. They selected 120 of the highest quality images, calibrated the light curves, and reconstructed the object's shape. The result left them silent. The object was neither round nor elongated, but had a flat, reflective surface, angled precisely toward the sunday. That observation revived an old theory, the self-sustaining energy system. If it could control its reflection, 3I Atlas might be maintaining its orbit by absorbing and regulating solar energy. It sounded like science fiction, but the math fit. The academic world split sharply in two. One side urged caution, warning that amateur data could contain optical noise. The other called it a rare gift, a global data set collected by hundreds of independent observers. Until then, all information about 3I Atlas had been locked behind institutional walls. For the first time, the public was watching an interstellar object directly, unfiltered, undefined, through raw images and pure curiosity. People began calling it the democratic era of cosmology. This servrum matterly bros for mannerly seconds in subbery, and well that the Weskers stug and their subbery, and ironically, it hadn't begun with a billion-dollar observatory, but with a dusty travel camera in the hands of an ordinary man in Chile. Amid this global wave of images, Avi Loeb remained silent. No interviews, no papers. He simply followed the open data being shared online. After nearly a month, he wrote a single line on his personal blog. The universe belongs to no one, and sometimes, those who aren't searching are the first to find. The sentence moved millions, not because it was scientific, but because it reminded humanity of something it had forgotten. That discovery is not the privilege of institutions, but the instinct of anyone who has ever looked up at the night sky. Among thousands of photographs of 3I Atlas, there was only one that made the entire scientific world stop. The photographer was a university student named Luka Nowak, living in Warsaw, Poland. He wasn't an astronomer, just a night sky photographer who loved taking long exposures through his small telescope. On the 17th of May 2025, Luka posted a simple image online with a quiet caption, "I think I captured it." At first, no one paid attention, but when a group of amateur image analysts enlarged the frame, they noticed something no one could believe. At the center of 3I Atlas's glow, there appeared a pattern of parallel reflections, 3 straight lines, evenly spaced, connected by nearly right angles. In astrophotography, such symmetry is impossible without a real reflective structure. No comet could create it. No random light could organize itself into geometry. The image spread like a silent explosion. Scientists were forced to take a closer look. Some dismissed it as a sensor glitch, but when the Geneva Observatory team examined Luka's original RAW file, they confirmed it was untouched. No digital interference, no noise anomalies. It was a real photograph. And if real, it meant 3I Atlas had a structured surface, possibly artificial. NASA didn't respond immediately, but 2 days later, a spokesperson said, "We cannot yet verify the origin of the image." However, the presence of 3 parallel reflective axes is unusual. "There's others for Gramley Wood," a short statement, but it triggered a storm. Every news outlet, science forum, and academic channel talked about Luka Nowak. The student became the accidental center of a global conversation. Physicists, astronomers, and even philosophers weighed in. A team from Oxford suggested that the parallel lines might be diffraction effects from dust or gas near the object. But when they simulated it with real data, the pattern did not appear. Meanwhile, a group in Japan used polarized light modeling and reached the opposite conclusion. Only a flat-surfaced object, reflecting light along fixed axes, could produce such geometry. In a matter of days, a single photo had ignited one of the largest dialogues about scientific perception in the 21st century. Online, people began calling it the geometry shot. One, Avi Loeb didn't comment directly, but during a lecture at Harvard, he said something his students instantly recognized as connected. If an object maintains geometric stability in a chaotic environment, then it's either a miracle or a construction. The phrase spread like a secret code among those following the 3I Atlas mystery, a line that confirmed nothing, but made millions of people feel, for the first time, that humanity might be witnessing an intentional pattern beyond Earth. Under public pressure, NASA reopened its imaging analysis systems. They cross-checked Luka's photograph with spectral data from the same time window. The conclusion was neither denial nor confirmation, only that the light from 3I Atlas oscillated on an 11-hour cycle, coinciding with the time of capture. That half-answer only deepened the intrigue. The whole world watched an object millions of kilometers away, and no one truly knew what they were seeing. Luka's photograph became a symbol of both doubt and wonder. It appeared on the cover of Science Illustrated, was printed in physics symposiums, and featured in countless analysis videos. A simple image, yet one that reminded people that science could still make the human heart tremble. Under its faint light, people stopped asking what 3I Atlas was, and began asking why it appeared now. An elderly astronomer in South Africa wrote in his journal, "Maybe it didn't choose anything at all. Maybe it's us who have finally changed enough to see it." That sentence closed a small moment in history, but opened an entirely new era. One where science was no longer confined to laboratories, but became a shared journey for everyone who still remembers to look up at the sky. After Luka's geometric photograph, the boundary between expert and amateur all but vanished. For decades, astronomy had belonged to laboratories, to giant observatories, to equations and data so complex that only a few could read them. But now, a small camera and the curiosity of ordinary people had changed the system itself. The agencies could no longer remain silent. NASA opened a public channel, inviting anyone to submit images and measurements of 3I Atlas. ESA followed, launching an open forum for global collaboration. Within a week, more than 40,000 people sent in photos, notes, and self-collected spectroscopic data. Never before in human history had an object from beyond the solar system been observed by so many. It marked the birth of something new, open science, where data no longer belonged to institutions, but to anyone who simply looked up. At first, many professionals were uneasy. They feared the flood of unverified data would drown out the truth. But as they began to review the submissions, they found details in amateur images that large observatories had missed. Tens of thousands of perspectives, stitched together, formed a continuous timeline of 3-eye atlas, something no single telescope could ever achieve. At an international conference, the director of the Geneva Observatory said plainly, "We are living in an era where the largest telescope is the community itself." And from that moment, a new field was born, citizen astrophysics. It did not replace institutional science. It expanded it, returning knowledge to the people where it had always belonged. When the global data was combined, something unexpected appeared. The light cycle of 3-eye atlas, recorded by NASA as 11 hours, was found to oscillate between 10.9 and 11.1, a small deviation, but one of enormous importance. It meant the object was not perfectly stable. Something inside it was adjusting itself. Research groups began discussing openly. Instead of trading papers, they spoke directly with the public. A physicist from Caltech wrote, "I've never seen a phenomenon like this. If anyone has data from May 5th to 7th, please share it. We might be missing something crucial." That post triggered another avalanche. Thousands uploaded images, video clips, and light readings. The data grew so immense that the servers had to double their capacity. But among that flood, a new pattern emerged, one that changed everything again. A team from Canada reported that the brightness of 3-eye atlas increased sharply whenever it passed through regions of magnetic turbulence. No comet in any known model behaved this way. No natural body reacted to magnetic fields with such precision. A young physicist remarked, "This could be an induction mechanism, like a device charging itself." The line was half in jest, but it froze everyone in place. If true, 3-eye atlas wasn't merely reflecting light. It was harvesting energy. NASA made no confirmation, but quietly redirected several radar arrays. And in the public data logs, new entries began to appear subtle, unannounced. No one said it aloud, but everyone had begun to see the sky differently. A user from Argentina wrote, "We used to think discovery was the work of scientists, but maybe discovery is just part of being alive. Writing Due, writing 2000 way." The quote spread across the world not for its scientific weight, but because it rekindled that ancient feeling, the pure curiosity that first drew humans to the stars. From 1,000 amateur photographs, a movement was born. People gathered for atlas hunts, on rooftops, on hills, by the sea, not to prove anything, but to feel the quiet unity of looking at the same sky together. And all the while, 3-eye atlas continued its journey, farther, colder, silent as ever, a quiet test from the universe itself, asking whether humanity still remembers how to wonder. As the global atlas hunt swept across continents, a small group in northern Vietnam began drawing attention. They weren't scientists. They had no grants, no observatories. Some didn't even own proper equipment, just old binoculars, improvised cameras, and a quiet belief that they too could see what the rest of the world was talking about. They called themselves "Những người lắng nghe bầu trời," the sky listeners. They didn't speak English, didn't read international reports, only caught fragments of the 3-eye atlas story through auto-translated videos. But every night, they would climb the cold rocks, set their cameras, and wait. On the 22nd of May 2025, the sky was perfectly clear. The air turned thin and cold, and Jupiter's low light shimmered along the horizon. A 16-year-old boy in the group adjusted his focus and noticed a faint moving glow, slower than a satellite, but steady. He steadied the camera, and took 5 consecutive shots. None of them knew those photos would travel farther than any of them ever had. 3 days later, when they uploaded the images to an international forum, a user in Canada spotted something strange. In the 4th frame, 3I Atlas no longer appeared triangular or evenly reflective. It showed a blurred hexagonal shape with 2 symmetrical points of light at its center. Professional astronomers dismissed it at first, a lens artifact. They said, a limitation of cheap optics. But when a team in India, using higher-grade equipment, attempted to replicate the observation, they got nearly identical results. That forced the world to look again, not just at the data from the credentialed, but at the work of people no one had ever heard of. European institutes stayed cautious. Some refused to recognize the images. Others quietly analyzed them. Meanwhile, online, millions watched and rewatched the sequence, asking the same question: if this is real, who saw it first? Not NASA, not ESA, but people who were never expected to believe or be believed. A journalist in Seoul wrote, "We are witnessing the greatest shift in science, where knowledge no longer flows from the center, but from the edges of the world." When light analysis software examined the Vietnamese images, it showed that the 2 central points were reflecting light 5 times stronger than the rest. It suggested a pattern, a navigation structure, a mechanism operating in cycles. NASA stayed silent. No confirmation, no denial. But on their public orbital tracking page, a new note appeared under 3I Atlas: extended spectral observation, data collection in progress. That single line meant only one thing: they had seen it too. The story spread everywhere. Headlines called the group the Sky Unlockers. The young boy who took the photos became a symbol of curiosity. When asked in a phone interview why he believed he could capture it, he just laughed and said, "Because the sky doesn't belong to anyone." In his quote, that answer reached deeper than any scientific statement ever could. Amid the noise and speculation, many began to sense something profound, that in trying to understand the universe, humanity was, perhaps, beginning to understand itself. Those once dismissed as outsiders now held data the entire world was forced to consider. Raw, imperfect images, but filled with a truth larger than resolution, that anyone can be an observer. And from that moment, a new phrase entered the conversation: the sky of the unbelieved. It was no longer just a slogan, but a movement, a reminder that knowledge has no hierarchy, and that sometimes the least noticed place is the first to see. 3I Atlas kept drifting outward, past Mars, its light fading, but every night, somewhere, someone still pointed a lens at the sky, not to prove, not to argue, but simply to remember that once we all looked up at the same star. By the time the last photographs were uploaded, they were no longer scientific evidence. They had become something else, a way for humanity to find itself again within the vastness of space. 3I Atlas had turned into a symbol, not merely of curiosity, but of that small, trembling strength that comes from knowing. Even with a single lens, human beings can still reach beyond their grasp. Hundreds of thousands kept capturing, logging, and sharing. Data about 3I Atlas was now scattered across dozens of independent servers, little dots of light across the planet, each one a person looking up. And in that constellation of gazes, the universe seemed to reflect them all back. No one spoke much about origins anymore. What people spoke of was connection, a collective silence spreading through forums and channels, not out of fear, but from a quiet understanding. They were all standing together, in a moment that would never come again. At Harvard, Avi Loeb returned to his lectures. He no longer spoke of 6 out of 10, nor of controversy. He simply said, "Sometimes, the universe doesn't send us an answer. It sends us a mirror. We look into it and see the edges of our own understanding." And DM20. The room stayed silent, because everyone knew he wasn't just speaking about 3i Atlas. He was speaking about everything science had forgotten: curiosity, humility, and the quiet faith that some truths cannot be measured. Months passed. 3i Atlas drifted farther away. Receivers still hummed softly, recording stable, uneventful data. The excitement was gone, but something gentler had replaced it. Scientists began to realize that it wasn't the object that had changed. It was the way they looked at it. They stopped trying to prove. They started listening. They no longer asked what it was, but why its existence made them feel so small. A philosopher in Vienna wrote, "Perhaps 3i Atlas carries no message at all. Perhaps it is only a reminder that life can still be found in the act of observing." This brings into him 610. Science, at last, returned to what it had once been. A journey of wonder, not certainty. A question, not a declaration. During community observations, people began turning off their lights, standing quietly beneath the dark, looking up without their phones. They said they wanted to feel, not just record. Children in the mountains of Vietnam, students in Warsaw, engineers in Canada, astronomers in Geneva, all looked toward the same invisible point, and for a fleeting moment, 3i Atlas ceased to be an object. It became a thread, a silent bridge tying all of them together. The universe had become a mirror, and within it, humanity saw not a distant comet, but itself, still trying to understand, still listening, still searching for meaning in existence. 3i Atlas kept moving outward, its light fading, but its echo remained, not in the data, but in the eyes of those who had once looked up. The sky did not change, only humanity did, just a little. October 3rd, 2025, 32 hours before 3i Atlas would pass the orbit of Mars. Across Earth, every major telescope shifted into continuous tracking mode. James Webb, stationed at L2, was ordered to focus its full infrared array on the southern hemisphere of the red planet. At NASA, orbital analysts confirmed the prediction: 3i Atlas would sweep past at 0.7 astronomical units from Mars's center, close enough to exert a faint gravitational pull. Everything began as expected. The object held its steady velocity, its light pulsing every 11 hours with perfect precision. Then, at 3:41 GMT, something impossible happened. The surface of Mars changed color. Not entirely, this beige, but across the southern hemisphere, a deep crimson bloom appeared, as if sunlight were being filtered through a thin, invisible film. It lasted less than an hour, then faded. Every observatory saw it. It couldn't be optical interference. The light oscillations were too regular. It couldn't be dust. Winds in that region were nearly still. The European Space Agency issued a cautious note: unidentified reflective anomaly, possible correlation with 3i Atlas. For the first time in recorded history, a planet's appearance shifted as a visitor from another star passed nearby. Hours later, data from Mars orbiter arrived. Infrared sensors showed a 2.6 degree rise in upper atmospheric temperature, a tiny number, yet enormous for a world as inert as Mars. Meanwhile, at Harvard, Avi Loeb's monitoring team received a 15-second data delay, as if the signal had passed through a layer of quantum interference. Loeb wrote only one line: 3I Atlas may be reacting. No one knew what he meant, but he was right to suspect something. The object's spectral signature began to shift, from icy blue-white to deep orange-red, then back again. A reflective body should not change its spectrum in real time. In 30 years of cometary research, no one had seen such behavior. If it was a physical anomaly, radiation, thermal expansion, chemical reaction, none of them matched the pattern. Then, in a moment of unguarded awe, a NASA engineer whispered, "It's synchronizing with the planet." The control room fell silent. No one confirmed it aloud, but everyone knew. Mars and 3I Atlas were interacting. The press called it the Martian effect. Speculation erupted. Some said the object emitted radiation that altered atmospheric particles. Others suggested a navigation protocol, as though the object were testing its environment. Loeb didn't deny either view. He simply said, "If 3I Atlas is communicating, its first conversation isn't with us. It's with Mars." When the time-lapse footage reached public channels, viewers noticed something chilling. The darkened red region on Mars had outlined a shape, a curve almost identical to the trajectory of 3I Atlas itself, a mirrored orbit projected across an entire planet. NASA made no statement. ESA stayed silent. But within scientific circles, the term correlative resonance began to circulate, a theoretical reaction between two distinct celestial bodies, never before observed. That night, millions looked toward Mars. Amateur telescopes recorded their final glimpses. Before 3I Atlas slipped into solar glare, some claimed the planet glowed brighter, as if returning the object's gaze. Others said it was human imagination, our need to find meaning in the silence. Yet no matter how it's explained, October 3rd, 2025, became the night Mars changed color, the first time in human history that something from beyond the solar system left a visible mark on the fourth planet from the Sunday. After 3I Atlas passed through Mars's orbital neighborhood, every monitoring system across the solar system began to twitch. Tiny oscillations, insignificant on paper, but enough to rattle the clean lines of every model. ESA's radar arrays detected a 0.02-second delay in reflected signals, a microscopic lag, yet it couldn't be explained by gravity or trajectory. When compiled, the data revealed something stranger. The delay repeated in a perfect cycle 11 hours, 4 minutes, exactly the same rhythm as the object's light pulse. Meanwhile, Mars orbiter registered a low-frequency anomaly. Not mechanical noise, not magnetic flux, more like a heartbeat. Every 11 hours, a single soft pulse rippled through the thin upper atmosphere, then vanished. Physicists had no name for it. Someone suggested echo signal. The name stuck. NASA's first public memo was blunt. Unidentified cyclical emission. Possible origin, interstellar object. Self-induced or reactive source undetermined. But for those who had watched 3I Atlas for months, it was the first quiet admission that the object was doing something. Avi Loeb wrote in his private log, "The signal is weak, but ordered. If it's a coincidence, it's a coincidence that can count time." He never published the line, but among academics, everyone knew what he meant. He was hinting at passive cosmic communication, not transmission, but resonance. Not a message sent, but a disturbance left behind, a rhythm that could carry meaning. When engineers mapped the echo, they noticed its amplitude increasing with each reflection, as if 3i Atlas were listening to itself and recalibrating in response. Physics had no mechanism for self-referential feedback in vacuum. Something was responding. A researcher at Caltech remarked, "We might be witnessing reflexive behavior, a system aware it's being observed. This is now the SATA grade in the Takum." The line spread like wildfire. NASA stayed silent. ESA offered no statement. And SETI, the agency built to find intelligent signals, admitted they had no framework for this because it wasn't communication. It was interaction, the physics of attention itself. Weeks passed. Radar logs showed the same steady pulse. When translated into sound, the signal became a low thrum, a slow, deliberate beat. People began calling it the heartbeat of Atlas. Audio simulations went viral. Millions listened in the dark, not understanding, yet sensing something alive in that rhythm. Neuroscientists said it was human pattern bias, our instinct to find emotion in repetition. But those who had followed 3i Atlas for years believed it was something real, a form of cosmic biofeedback hidden in data. Loeb's comment resurfaced. Maybe it isn't alive, but it certainly knows how to exist. That line split the community once again. Was it poetic exaggeration, or the first honest description of a phenomenon beyond physics? As debates raged, the pulse continued. Every 11 hours, 4 minutes, without fail, not drifting by even 1,000th of a second. If it was random, it was the most perfect randomness ever recorded. NASA stopped calling it data noise. The new term, unidentified periodic phenomenon, neutral, non-committal, but no longer dismissive. Then the mathematicians noticed something new. Every 7th cycle, the waveform subtly changed. A faint variation, as if someone or something was counting to 7 before adjusting the tone. No one dared call it a code, but the idea took root. Because if there was a pattern, then 3i Atlas wasn't just reflecting, it was responding. A professor in Zurich wrote quietly, "Perhaps it isn't a creature, but a memory." In the Spiegel for the Warns, a machine older than stars, built to sustain a heartbeat of data for millions of years, waiting for a sky quiet enough to echo back. No one knows if that's true, but the phrase, "the universe remembers itself," began to appear in papers, forums, and midnight discussions. And from that point on, 3i Atlas was no longer just an interstellar object. It had become a question about whether memory itself might be the oldest language in the cosmos. 3 days after 3i Atlas swept past Mars, the planet began to tremble softly, rhythmically. Not earthquakes, not storms, just faint pulses of atmospheric pressure every 11 hours. The exact rhythm of the object's light. From orbit, Mars orbiter captured new images of the southern region, the same area that had reddened during the encounter. Across the terrain appeared thin, luminous streaks stretching east to west. They weren't bright, but their reflectivity was measurable and unnatural. When NASA overlaid the data, the lines didn't match any geological feature. They cut across crater rims, over ridges, through plains, a geometry no wind could carve. A researcher in Pasadena called it echo surface. He said, almost poetically, "It's as if Mars is answering in light." The phrase was meant as metaphor, but spectroscopy confirmed something impossible. The brightening synchronized precisely. with the returning echo signal from 3I Atlas. Two bodies, hundreds of thousands of kilometers apart, flashing in rhythm. Theorists began speaking of interplanetary resonance, the idea that energy could bridge worlds through shared spatial fields. No one dared to affirm it. But data does not lie. ESA's atmospheric logs showed Mars retaining pads higher than normal upper air temperatures for several days. The glowing regions did not fade. They sharpened. In Japan, a plasma simulation team tried to reproduce the event. All failed. No known model could explain how a planet might remember a passing object. But if it was memory, it was real. On Earth, scientists watched the images with a mix of wonder and restraint. They avoided the word scar, yet everyone felt it. Something had happened on Mars, and it hadn't disappeared when 3I Atlas left. Avi Loeb reviewed the image sequence. He offered no statement, only one quiet line in an email to colleagues. The echo isn't only in the signal, it's in the planet. When the images were contrast enhanced, the streaks connected, forming a faint hexagonal lattice spanning hundreds of kilometers. No one published it, but those who saw it agreed. It looked arranged. NASA went silent. ESA froze new releases. Official language shifted to data under further review. The public, however, didn't wait. Amateurs compared archival images from the Mars Reconnaissance Orbiter. Before October 3rd, the streaks did not exist. They appeared immediately after 3I Atlas passed. Online, they earned a name: the Scars of Mars. No one knew what they were. Perhaps a transient chemical reaction, perhaps a trace, a handshake between two worlds. Philosophers entered the debate. One wrote, "Maybe Mars keeps memories not in words, but in light." In labs around the world, even Loeb's skeptics fell quiet, not because they agreed, but because there was nothing left to disprove. Science was now staring at the immeasurable, etched plainly across a planet's face. Weeks later, the lattice faded. By month's end, it was gone. But when Mars returned to the same point in its orbit, a single bright dot appeared, right at the heart of the old region. A solitary beacon, steady and clear, emitting the same spectral signature as 3I Atlas. No one could explain it. No one dared claim it. But somehow, a fragment of the visitor seemed to remain. That night, Avi Loeb wrote in his notebook, "If Mars has truly replied, then we have just witnessed the first conversation between two worlds." It to die. He never published the line. It stayed among his private notes, another entry in the long, silent record of a visitor that came, departed, and left behind echoes science still cannot name. When 3I Atlas departed Mars's orbit, telescopes across the solar system recorded something that should not have been possible. The object slowed down, only slightly, a mere 0.3% drop in velocity, but in interstellar mechanics, that difference was monumental. No gravitational force nearby was strong enough to cause it. No known physical law could justify a self-breaking interstellar body. At first, NASA blamed a calculation error, but 3 independent observatories returned identical results. The anomaly was real. 3I Atlas was decelerating. And not just that, its trajectory had shifted by 0.004 degrees. A tiny deflection, yet too precise to be random, as if something or someone were gently correcting its course. Avi Loeb said quietly, "That's not dynamics, that's behavior." He didn't elaborate, but everyone understood what he meant. An object capable of adjusting its own speed, is an object that responds to its environment. The scientific community resisted. Theories multiplied: outgassing, gravitational drag, magnetic drift, each proposed, each disproven. Spectral data showed no gas burst strong enough to alter motion. Mars's gravity was too weak to explain the curve. One by one, the natural explanations fell away, leaving only silence. In his memo, Loeb wrote, "To slow down is to decide, not chance choice." It was heresy, because science doesn't use the word purpose, but science has often begun with ideas it refused to name. When radar data was modeled in 3D, analysts noticed something new. 3I Atlas was rotating slowly on its axis. One full rotation every 24 hours. Exactly one Earth day. A coincidence, perhaps, but a strange one. No one dared say it was syncing with the human planet, yet the numbers matched perfectly. A few joked, "Maybe it's waiting for us to understand." Within days, no one laughed anymore. Orbital simulations showed the object swaying, a faint side-to-side correction before returning to its path. A movement like a directional check. No natural body could do this without fracturing. Only something with an internal stabilizer could. An internal ESA engineering brief concluded, "If this is a device, its control system surpasses any known human technology." The report was never published. Someone leaked it. The world read it. And once again, 3I Atlas became the center of everything. While institutions argued, amateur astronomers kept watching. They said its light seemed softer, cooler, as though the object had gone into a resting state. But when images were magnified, some showed tiny points of light detaching, then rejoining, like fragments orbiting their source. Researchers in Tokyo called them sub-objects. Nobody knew if they were real or noise, but the thought that 3I Atlas might deploy something rattled the scientific world. NASA dismissed the claim, but afterward, every official image was cropped tighter around the object, cutting away its immediate surroundings. No one said it aloud, but everyone knew. Something was being hidden. Avi Loeb remained silent. No interviews, no articles, only one remark in a closed symposium. If it can alter its speed, then it isn't merely an object. It's an entity. No one responded. Only the faint hum of ventilation and screens flickering with data that refused to make sense. The next day, 3I Atlas moved on. Its velocity normalized, its path stabilized, but no one could explain why it had slowed down at all. The phenomenon entered the official record under a new phrase, anomaly of intent, a definition that acknowledged, without admitting, but among those who had watched it from the beginning, a quiet conviction took hold that somewhere out there, in the deep black between stars, exists something that not only moves, but pauses to look around. As 3I Atlas continued on its journey, it drifted into the glare of the Sunday. One by one, observatories lost sight of it. Radar returns faded. Spectral readings went flat. By October 17, 2025, NASA announced that the object had entered the region of total solar occlusion, the place where sunlight drowns out everything else. No spectral signature, no infrared reflection, only silence. Nothing unusual, at least on paper, but this time, the silence felt different. Everyone knew 3I Atlas was no longer just a passing visitor. For weeks, it had rewritten how humanity looked at the cosmos. It had forced scientists to redraw the boundaries of certainty to admit that some truths remain beyond explanation. In observation centers, blank screens still glowed in the dark. No new data, only habit, as if someone, somewhere, was still waiting for a heartbeat to return. Avi Loeb wrote the final line of his daily report. Atlas, currently unobservable, awaiting emergence from solar conjunction, and the danger his self unwinted to them, with the ones of way, but those close to him recalled something else. That day, before leaving the lab, he stood silently before the last image. A faint wash of light, a single pixel at the edge of the frame. No one could tell if it was 3i Atlas or random noise, but he watched it for a long time, as if trying to memorize the place where it vanished. Around the world, amateur astronomers turned their telescopes toward that same patch of sky, the space where the object had once passed. They saw nothing, only a weak halo on the sun's edge. Some said it felt like staring into memory itself, something half there, half gone. They called it the final gleam, others, the hollow moment. But everyone felt it. The universe had set aside a silence just for it. Subsequent reports confirmed that 3i Atlas continued moving steadily, still deviating by 0.004 degrees, still traveling slightly slower than predicted. No collision, no instability. It simply kept going. Not gone, but not entirely departed either. A physicist in Europe wrote, "Perhaps 3i Atlas never left the solar system. Perhaps it's simply where the light can't reach." From that line came a new expression. Beyond the boundary of light, it wasn't about distance. It was about perception. The moment when humanity must accept that existence doesn't vanish when sight does. The observatories shut down one by one, yet thousands of messages appeared across online logs. "I saw it. I believe it's still there. I think it's listening." No reply ever came, but the messages kept appearing, a pulse in text, the collective breath of a world that refused to forget. Avi Loeb closed his research chapter with a single sentence. Whether natural or artificial, 3i Atlas achieved what nothing else could. It made us listen to the universe through silence. This earned the Lumint, the Lumint, the Lumint, the Lumint. When he signed the final report, a young researcher asked softly, "What if it comes back?" Loeb smiled. "Then at least," he said, "we'll know it remembers the way." When 3i Atlas entered the sun's glare, its image vanished, but the spectra remained. Thousands of lines of data, each a trace of how the object once reflected light. At first, no one paid much attention. Metal spectra were routine housekeeping, just numbers on screens, until a young analyst in Geneva noticed something impossible. In the reflection spectrum of 3i Atlas, the iron Fe absorption line, normally dominant in comets, was nearly gone. In its place, deep, clean bands of nickel, Ni. Across all known history of astronomy, every comet ever studied showed more iron than nickel. Yet 3i Atlas inverted that rule completely. Nickel made up almost 80% of its metallic signature. Iron existed only in trace amounts. No one believed it at first. The measurements were repeated. 3 observatories, 3 results. Identical. A paper was drafted under the title, "Inverted Metal Spectra, Evidence of an Anomalous Formation Mechanism in an Interstellar Object." But before publication, it was blocked. NASA requested verification. ESA sealed the original data and suspended public access. Only a handful of internal groups were allowed in. Inside those restricted meetings, the arguments turned fierce. If 3I Atlas truly had such a high nickel ratio, it could not have formed in any natural cometary environment. Nickel requires extreme heat to condense, thousands of degrees beyond the conditions of any frozen body. That meant one of two things. It had survived intense stellar temperatures, or it had been built. A chemist murmured, "That composition looks more like an alloy than a meteorite." The room went silent, because alloy meant engineering. When Avi Loeb read the report, he didn't look surprised. He nodded slowly. Nickel withstands heat and radiation. If a civilization wanted to send something far, they'd choose nickel. Within hours, headlines exploded. Loeb, 3I Atlas may be manufactured, but he never confirmed. He only said, "I don't assert. I follow the data." Institutions scrambled to re-examine every measurement. Theories flooded in. Solar light distortion, metal crystallization in extreme cold, instrument bias, none fit. Nickel reflects light at specific wavelengths, and 3I Atlas matched those wavelengths exactly, with mathematical precision. No noise, no error. A physicist scribbled a private note in the margin of his draft. "We are looking at something made to be seen." It wasn't part of any official paper, but it captured what many felt, that 3I Atlas wasn't simply reflecting light, it was presenting itself. When NASA quietly reopened partial access to the locked datasets, amateur analysts confirmed the anomaly. Simple home-grade software showed the same gleaming nickel peaks, like bright ink stains in the data. Someone on a public forum wrote, "This isn't a comet, it's a shell. Something built to survive heat." From that moment, a new phrase spread, the nickel shell. A hypothesis was born, that 3I Atlas was encased in a metallic sheath. If true, it wasn't a remnant of nature, but a relic of technology. NASA remained silent. ESA offered no comment, but SETI, after years of quiet, released a single, cautious statement. The object's origin remains undetermined. All possibilities should be considered. All possibilities, the polite, institutional phrasing for the unthinkable. Among scientists, few said it aloud, but everyone knew what it implied. If nickel truly dominated its structure, then 3I Atlas carried within it something that no longer belonged to astronomy alone. When the nickel spectrum results spread, science itself seemed to recoil. No one wanted to believe that an object from beyond the solar system could carry the fingerprints of technology. Emergency conferences were called. Scientists from NASA, ESA, JAXA, and Harvard gathered to confront a single question: how could they explain the anomaly without invoking intelligence? They built lists: heat, pressure, impact events, solar radiation. Every idea was modeled, simulated, tested. Thousands of computational hours were burned. Every model failed. Nickel simply could not exist in such abundance without selection or refinement. In nature, iron always dominates. Even planetary cores obey that rule. An Oxford physicist finally said, "We're trying to make the universe agree with what we wish were true." Silence. Because everyone knew he was right. For decades, science had been comfortable inside equations. Everything measurable, calculable, reproducible, but 3I Atlas didn't fit the math. It stood just beyond the reach of theory. Physicists began calling it the natural limit, the moment when theory no longer holds. The final thin shell of understanding beginning to crack. Laboratories across the world reopened archives, re-examining spectra from centuries of comet studies. The results only deepened the wound. No recorded object had ever shown a metallic ratio like this. Not one. A NASA team proposed an ancient collision hypothesis. Perhaps Dry Eye Atlas had exploded, vaporizing its iron while heavier nickel survived. But the spectral data ruined that hope. Nickel appeared evenly across the surface. No burn signatures, no dispersal pattern. If it had ever exploded, it should have been dust by now. Someone joked weakly, "Maybe the universe made this one just to mess with us." No one laughed. Avi Loeb no longer argued. He simply wrote in his notebook, "The natural hypothesis is running dry." And from that line, a new phrase took root in scientific vocabulary: natural exhaustion. It didn't claim 3i Atlas was artificial. It only admitted that natural explanations were running out of road. Major journals refused to publish further analysis. No theoretical framework, they said. Yet in smaller groups, scientists kept working, not to prove anything, but to sit with the discomfort of what they could not explain. In classrooms, professors began using 3i Atlas as a parable of epistemic limits, not because it was strange, but because it reminded humanity that science is not a fortress. It's a path, still being cleared a little further each day. During one lecture, a student asked Loeb, "If this isn't natural, should we be afraid?" He smiled. "No, we should only be afraid when we stop asking questions." The nickel data remains in storage, quiet, untouched, a digital fossil of the night the known world blinked. And whenever someone reopens the file, the same question rises again, soft and enduring. Was this the work of nature, or of something beyond it? It doesn't need an answer yet. The question itself is what keeps science alive. After the nickel reports were suspended, part of the 3i Atlas dataset was quietly moved into a private NASA archive. Access was restricted. Only 12 people on Earth could still open the original files. The official explanation was to verify data reliability, but everyone understood. It was a way for science to shield itself from what it wasn't ready to face. Among those 12, 4 made personal backups, not to leak, but to protect. They feared the data might someday vanish. They called themselves simply the Keepers. No organization, no funding, just a handful of scientists, a few engineers, and one former ESA technician. They met online, traded encrypted packets, and kept total silence. To them, 3i Atlas was no longer just research. It was proof that the universe still contained rooms no one had opened yet. One of them, a signal analyst in Canada, wrote in his journal, "We're not here to build a theory. We're here to make sure the truth doesn't get deleted." They worked in secret. No budgets, only devotion. One handled spectroscopy, another reconstructed trajectory, another combed through old radar logs for echoes the official analyses had missed. After months, something surfaced. In the raw radar data, they found gaps, segments of waveform abruptly cut mid-sequence, as if erased by hand. When they stitched the remnants together, a pattern emerged. It wasn't noise. It was a repeating oscillation. The intervals between pulses matched the rotation period of 3i Atlas. When plotted over time, the waveform formed shapes hauntingly close to binary code. No one dared call it a message. They called it a recurrence, a pattern that refused to die. One of the keepers handwrote a letter to Avi Loeb, no email, no signature. It contained only one line: "We found what they removed." There was no reply. But weeks later, Loeb published a short essay titled "On the Silence of Restricted Data." He never mentioned 3i Atlas. He didn't need to. Those who followed knew exactly what he meant. The essay disappeared after 3 hours. Researchers archived mirror copies before it vanished. From that point on, the phrase data silence entered the lexicon, an unspoken metaphor for the things science knows but cannot say. The keepers went quiet. No more reports, no more communication. But somewhere, on anonymous servers, the datasets remained alive in digital hibernation. A note from their internal log reads, "We don't know what this is, but if it ever comes back, we need to remember how to recognize it." And so they continued, silent, patient, preserving what might be, the universe's own act of remembering. When the rumors of the keepers began to spread, the scientific world slipped into a strange mood, half curiosity, half fear. No one knew who they were, but everyone had heard the same whisper, that somewhere, a small group still held the original 3I Atlas data. And in science, that was more dangerous than any theory. The press called it the first data schism in modern scientific history, the Dana Badara Vuzo, not because someone had falsified results, but because, for the first time, knowledge itself had been split into what could be spoken and what could not. Institutions scrambled to deny everything. NASA claimed there were no keepers. ESA dismissed it as unverified speculation. But inside the community, people knew when something is denied too quickly, it's rarely all false. A professor in Munich told a colleague quietly, "It doesn't matter who they are. What matters is that they chose to keep it." That single sentence rippled through private forums. Soon, old datasets began reappearing. Copies of copies, graphs without provenance, transferred from hand to hand like samizdat manuscripts. No one could control the flow anymore. A celestial object, hundreds of millions of kilometers away, had become the center of a struggle between transparency and control. Veteran scientists warned that chaos would erode credibility. Others answered, maybe credibility was never as pure as we believed. It was a fracture small, at first, but like every fracture in history, it widened. Science, long built on openness, now faced an ancient question reborn. When should truth be kept, and when should it be shared? Conferences began to speak in a new language, the ethics of data. Researchers were forced to ask themselves whether there should be boundaries to curiosity. Avi Loeb stayed silent. He wrote a single line in his notebook: "Truth never disappears, it only waits." Those who once criticized him now quoted him, not from belief, but from the absence of any better explanation. New papers slowly trickled out, careful to the point of emptiness. They spoke only of unidentified optical phenomena, non-standard spectral behavior, and signal deviations beyond expected background. No one said nickel again, but the public had already made up its mind. Something had been hidden. Online, the Keepers movement was born, a quiet collective, insisting that science should never be owned by authority. They weren't rebels, they simply wanted knowledge, to move as freely as the light it came from. A digital artist created a piece titled "The Unseen Spectrum." It showed 3I Atlas as a cloud of glowing nickel points, each dot representing an unnamed researcher who had refused to delete. The image spread across the world, and in that silence, people began to understand. Sometimes, knowledge isn't lost, it just changes where it chooses to be seen. 3 months later, after the noise had faded, NASA quietly reopened partial access to the data. No press release, just one line: metallic spectrum of 3I Atlas verified. no details, no summary. But for those who had kept the copies, that was enough. A message hidden between the words. Nothing they saved had been in vain. One of the keepers wrote in his final note, "We are not preserving data. We are preserving memory." After months of debate, the physicists stopped asking where 3I Atlas came from. They began to ask what it was made of. Nickel, the metal that had unsettled an entire discipline. Under extreme cold and immense pressure, nickel remains astonishingly stable at the quantum level. It doesn't decay. It doesn't magnetize. It can hold equilibrium for millions of years. One researcher remarked, "Nickel doesn't just exist. It remembers how it was arranged." It sounded poetic, yet it opened a new frontier. The idea that matter itself might remember. If every atomic layer of 3I Atlas had once been precisely ordered, and that order had survived a journey across billions of kilometers, then the structure was not accidental. It was a record. Computer models showed its spectral reflections repeating with uncanny precision. Not chaotic, but patterned, like code written in the language of light. No one could prove it was a message, but the perfection defied randomness. A quantum physicist in Tokyo wrote, "Perhaps intelligence doesn't require consciousness. Perhaps it's simply matter that knows how to hold information." From that line came the theory of material memory, the idea that the universe forgets nothing. Every vibration, every particle, every photon leaves its trace in the fabric of existence. If that were true, then 3I Atlas might be the archive of that memory, a drifting vault of ancient data, silent, yet still carrying the record of itself. Avi Loeb said during a quiet symposium, "Maybe we're looking at the universe's own memory, wrapped in metal." There was no proof, but for many, it felt right. That perhaps the object's purpose was not to arrive anywhere, but simply to endure long enough to be seen. A Geneva engineer closed his final report with one line, "Iron rusts. Nickel does not. It was built to last." No one dared call it artificial anymore, but no one called it natural either. The universe, it seemed, keeps what it must remember, and sends it forth in the simplest form imaginable, a quiet piece of metal, drifting through darkness, carrying the memory of every gaze that ever found it. November 2025. 3I Atlas vanished from every system of observation. No reflected light, no radareko, only an endless stretch of missing data, a hollow corridor in the record of the sky. The observatories kept running, lenses remained fixed on the same coordinates, but the monitors showed nothing but black. All systems nominal, only the universe itself had gone silent. The silence seeped into the research centers. No more emergency briefings, no new projections, only strings of perfect, meaningless numbers, accurate, precise, and utterly still. Though no one spoke it aloud, everyone felt the same uncanny thing. The object was still there somewhere, its light merely hidden behind the Sunday. The first month passed slowly. Humanity entered an era of watching without seeing. Telescopes stayed awake through the long nights, less out of duty now, more like a ritual, an act of faith in the act of looking. Data continued to flow, even when there was nothing in it. Some files contained only background noise. Others were pure flat lines. Yet within that emptiness lay a strange beauty, the quiet patience of waiting itself. Science, people realized, does not always advance through discovery. Sometimes it grows in the pause between observations. The cosmos moves the same way, through repetition, through the long spaces between its own heartbeats. Researchers began to call this stretch the absolute quiet, not because the signals were gone, but because humanity had finally learned to accept silence as part of the data. Outside the main networks, smaller observatories kept their vigil. No new findings, just the gentle persistence of a civilization that had learned endurance. In that silence, people started to reconsider what it meant to observe. Perhaps observation was never about discovery alone, but about understanding that there are times when the universe chooses not to speak. The first month ended that way. No headlines, no breakthroughs, no conclusions, only the quiet realization that every light, whichever reflected, must one day dissolve into shadow. And sometimes it is in that shadow that humanity learns more than light has ever told. December. After weeks of absence, a faint band of light began to appear near the edge of Venus's orbit. No one called it 3I Atlas right away. It was just a dim speck, barely bright enough for radar to notice. The signal was so weak that every system suspected interference. Yet, amid the dense background of solar radiation, it repeated with a familiar rhythm, one cycle every 11 hours, an old frequency, returning in silence. No one knew where the object truly was. It might still have been within the solar glare, or perhaps it had moved a little farther out. But the reflected light proved one thing: it still existed. Observatories synchronized their instruments, boosting their reception power. The first data arrived fragmented, only a few tiny pulses in the infrared spectrum. But within thousands of lines of noise, patterns began to emerge. Steady rhythms, identical to those from the previous month. No clear image, only sequences of numbers. Yet for those who had followed it for so long, that was enough. Some researchers called it the pulse of rebirth. The object didn't seem to emit more light. It was simply responding to the light around it, in its own way. Signal strength increased over several days, but not steadily. Each cycle showed slight variations, as if it were recalibrating its trajectory. After a long period of dormancy, simulations suggested that 3I Atlas had drifted about 0.02 astronomical units from its previous path. A minor deviation, yet one hard to explain without intentional control. Its return was described as the echo of an unanswered question. No shape, no surface to see, only a dim glow and a rhythm that never faltered. Many began to believe that 3I Atlas had shifted states, as though it had just awakened from a long sleep. Analytical systems detected something unexpected. Its reflected spectrum was no longer bluish-white, but pale green, a hue rarely seen in natural celestial bodies. Scientists withheld conclusions, but those who understood reflected light knew. Color is never random. It is born from structure. 3I Atlas had changed, not dramatically, but enough to show it was no longer the same. The signal near Venus's orbit persisted for 2 more weeks. Then the light slowly dimmed. Once again, the object slipped out of sight. The data left behind was insufficient to form an image, only enough to prove that it was still active. The universe fell silent again. But this time, the silence didn't feel cold. It felt like a breath. Between 2 moments of appearance, the pause of a being, moving through the sun's alternating realms of light and shadow. Amid the stream of faint signals, something unusual began to emerge. The light bands from the edge of Venus's orbit didn't flicker randomly like background radiation. They pulsed with rhythm, with sequence, with structure. The spectrum split into thin, repeating layers, aligned in perfect order, like the heartbeat of a system running slowly, deliberately. The observatories made no public statements, but the data was preserved carefully. Wave sequences were aligned, and a pattern appeared. Every seventh cycle, the amplitude shifted slightly. A rule, not loud, but steady like breathing. It became clear to many. This could not be a natural signal. Reflected light always fluctuates, but never in such exact repetition. No one dared to make a formal claim, yet everyone understood. Some kind of language was hidden in the light. The data was reprocessed with real-time algorithms. When charted, the wave peaks formed geometric shapes, almost like concentric petals, opening and closing with each pulse. No one could decode the meaning, but intention was undeniable. It wasn't random interference, nor the product of sensor error. Light began to be seen as a medium of communication, not to send words, but to transmit structure. Some scientists called it the language of reflection, a form of dialogue the universe might use to store information without sound or symbols. In space, light is the only message that never dies. Every photon carries the imprint of where it has been, and now, the photons reflected from 3I Atlas seemed to be telling a story humanity did not yet know how to read. As data amplification continued, the wave models revealed integer sequences, no clear mathematical logic, but perfectly repeating over 72 hours of observation. Some believed it was resonance between 3I Atlas and sunlight. Others thought it was an active response, a way for the object to announce that it was still awake. Either way, light remained the only language left. After 2 months of silence, 3I Atlas did not return as an image, but as a structure of light, wordless, soundless, existing in the purest form of information. And somewhere in space, beyond the orbit of Venus, the object kept reflecting, sending its steady sequences outward, as if writing across the sky, a message that only the universe could understand. After the light signal stabilized, the observation networks began recalculating the position of 3I Atlas. The orbital equations were refreshed, and a subtle deviation appeared. At first, it was only a few thousandths of an astronomical unit, too small to be considered an event, yet enough to force every model to start again. The object was drifting away from its predicted path, not suddenly, but steadily, a motion that seemed deliberate. In space, everything is governed by gravity, but 3I Atlas moved in a way that didn't fully obey that rule. Its velocity did not increase, yet its direction gradually changed, as though being adjusted gently, continuously. No external force could explain it. No collisions, no solar wind strong enough, no gravitational interaction visible. Some proposed self-regulating gas emissions, but no data supported that. No vapor trails, no thermal signatures, only the path. Changing, the shift unfolded slowly, evenly, with precision impossible to mistake for chance. When all the models were updated, the conclusion was the same. 3I Atlas was correcting its own course, heading toward an entirely new point. Not into the depths of space, but upward, above the plane of the ecliptic, a region where almost no planets travel, an empty zone, yet the perfect vantage point from which to observe the entire solar system. That motion silenced many. If random, the odds of such an adjustment were nearly zero. It wasn't flying, it was choosing, a path not written by physics, but by intent. Researchers were left with only 2 possibilities: either an extraordinarily rare natural phenomenon, or a self-operating system. Both options felt impossible. Yet every data set agreed. The orbit had changed. And in science, a small change in trajectory means every previous theory must be rewritten from the start. Those who had tracked the object since its first appearance knew this was no longer a passive journey. The universe was no longer just moving, it was acting. 3I Atlas was no longer the fading trace of a comet. It had become a question, gliding slowly through the dark, keeping its own rhythm, unhurried but certain. Among billions of silent stars, it was the only thing still choosing where to go. After the announcement of the orbital change, Earth entered a state of quiet astonishment, a collective awakening wrapped in disbelief. No alerts were issued, no emergency statements released. Only short, restrained reports passed discreetly between observatories. The data confirmed what many had feared to whisper. 3I Atlas had adjusted its own trajectory. It was no longer a body in freefall, but a traveler on a deliberate path. Slow, measured, precise. That revelation spread swiftly through the scientific world. Meetings sprang up across observatories and research centers. No conclusions were reached. Only hypotheses collided, softly, cautiously, like sound absorbed in a vacuum. Half the world believed the object was merely reacting to solar wind and gravitational drag. The other half suspected a controlled mechanism, something unknown, something purposeful. While the institutions debated, radar systems in Europe, America, and Japan all registered a stable reflection from the same region of space. It was no longer a dim speck, but a distinct zone of periodic light, pulsing at fixed intervals, immune to solar interference. Such perfect regularity could no longer be dismissed as coincidence. For the first time, the world's major space agencies agreed to release joint data. No one wanted ownership. The object belonged to no nation, but to the collective curiosity of humankind. Late-night broadcasts replayed the same simulation, a single point of light, breaking away from its predicted orbit, rising slowly above the plane of the ecliptic. No sound accompanied it, only the faint rhythm of reflected light. Yet that light carried a feeling that the universe itself was moving with intention. Online, the debates shifted, no longer about what it was, but why. Why had it returned? And why now? Amid the questions, one truth stood out. Every major telescope, radar array, and sky monitoring network on Earth was now pointed toward the same coordinate. For the first time in history, all of humanity watched a single celestial object, not out of fear, but out of wonder. The silence of 3I Atlas did not inspire panic. It felt intimate, as if something vast had finally turned its gaze toward us, quietly asking to be noticed. Science became humble again. Equations were rewritten, but everyone sensed that what was unfolding might exist beyond the reach of mathematics. Earth kept turning, cities glowed, lives continued, but in countless minds, the sky no longer felt empty. Something was out there, moving slowly, along a path of its own. It left no words behind, but it made an entire planet fall silent and listen. After the orbital shift, every observatory began collecting data on the density and mass of 3I Atlas. The first measurements made no sense. The object reflected light as if it were made of solid metal, yet its calculated mass was astonishingly low, almost hollow. Gravitational models showed that its pull did not match its apparent size. At first, scientists blamed instrumentation errors, but after hundreds of repeated measurements, the results remained the same. Here was an object with a mass of roughly 33 billion tons, but with a surface reflection suggesting something thousands of times lighter. Such a thing should not exist within known physics. Any structure of that density should collapse under its own gravity or coalesce into a small planet. Yet 3I Atlas did neither. It moved with perfect stability. No chaotic spin, no heat emission, no energy discharge. The reports called it the mass paradox, an existence balanced between two extremes, too heavy to be hollow, too light to be a world. Its perfect equilibrium led some to propose that an internal regulatory mechanism might exist, a system capable of maintaining balance by subtly adjusting its density over time. Computer models attempted to simulate such behavior. If the internal density oscillated rhythmically,